Hi Year 7, this is Mrs. Faint here. Instead of a live lesson today, you're going to work from this recording that I've made. The good thing about these recordings are that you can pause them at any time using the pause button down here and work from the slide at your own pace. So this lesson is about indicators and pH, and it's part 1. So could you put that down as a title for me? And when you're ready, let's move on. So last lesson we were looking at some of the hazard symbols, and these are the new versions of some of the hazard symbols, although I don't think you saw the last one down here. So let's have a quick go at a starter. You don't have to draw these out, but quickly write down on a piece of paper or in your book what you think these are. I'm going to pause the video, you write them down, and then when you're ready you can start it again. Okay, so I hope you had time to do that. Pause the video as I said if you need more time. So the first one, the skull and crossbones, do you remember that's toxic? That means it can cause death. The second one with the flames in, that means it's flammable. And this one is the new version of the one that we had, which was a cross with a little H by it. So that means it's a health hazard, it's harmful in other words. This new symbol replaces the one that we had as a cross with a little I next to it. So over the last lesson and this one I've shown you both versions because both are still in use. This one isn't quite as bad as the last one, but it means be careful with this. Take caution because this is an irritant. This one down here, very important for our acids and alkalis topics because this means it's corrosive. So this shows that the liquid here is eating into a hand or eating into a piece of metal. And this one we didn't see yesterday, but it's quite a fun one. It's explosive. Hopefully we won't be having too much of that. Okay, so what I want you to think about today is if I gave you something that was an acid or an alkali, they look very similar. In fact, they look very similar to a beak with water in it as well. So how could we tell if a substance we had was an acid or an alkaline or neither? So this word here, base, we'll discuss what this means today and the difference between that and the word alkaline that we used last lesson. Okay, so pause the video, have a think about how you might be able to tell, and then we'll move on. Okay, so this is what we're going to achieve by the end of today. We're going to be looking at some examples of indicators, and we're going to be looking at this thing here called a pH scale as well. So we're going to look at what an indicator is, what the pH scale means, and then identifying which indicator we could possibly use. So then, the word definition sheets, which you'll find attached to class charts, do you remember this word here? This is from the first lesson. We're currently on lesson number 3. What is the word that describes a change in state where you don't make anything new? Do you remember? Okay, it's a physical change. And when we have a chemical change where we've made a new substance, the word reactants means the substances that join together to make something new in the chemical reaction to make the products. Now the other one that was covered up at the beginning was corrosive, and that's a substance that can burn your skin or your eyes. Now you can go back to what you put last lesson when you wrote down for me some information about acids and alkalis, and you can top up what you wrote with what is on the slide here. Okay, now I'm going to explain what this word pH means in a minute, but here we've got down that acids are substances which are corrosive, can be corrosive. They are, I think we said last lesson, there are opposites of alkalis. So this will tell us what these two words mean here. So bases are actually the chemical opposites, and our alkalis are types of base that dissolve in water. And almost all of the alkalis that you deal with in school will be dissolved in water, which is why we often use this word. Okay, so acids of pH less than 7 and bases and alkalis, therefore, are pH value higher than 7. So we'll come on to what the definition of pH is in just a minute. Okay, so at this point what you need to do is pause the video go back to class charts, and I've attached this as a link there. It's a fantastic video. It's only 5 minutes long, but it gives you lots of information. So you can pause it, you can make notes, or you can watch it once, run through the rest of the PowerPoint, and then go back and make notes from it. So pause the video now, off you go, click on the link, watch the video, and we can take it from there. Okay, welcome back. So here we're going to answer our starter question. How could we tell the difference between our acid, our alkali, and our beaker of water when they all look exactly the same? Well, we use indicators. Just like an indicator on a car will show drivers behind which way a car driver is going to turn, then so too an indicator here will tell us whether we've got an acid or an alkali. So basically, it's a chemical that changes colour. Now, litmus is a really popular indicator. Okay, so you can have it in paper format, which is a bit of paper here that you dip into your solution, or you can have it as a solution itself. Okay, so remember our acid and our alkali and possibly our water were clear on that first slide. So if we dipped paper into the solution and it was red at the end, then we would have an acid. And if we dipped our paper into alkali and it was blue at the end, then we would know that we had the alkali. The same goes for the solution. So what's happened here is we've poured some litmus solution in and the whole solution has turned red. So we know we've got an acid, and here the whole solution has turned blue. So whether you use paper or litmus as a liquid, as a solution, it doesn't matter. They both work the same way. And you'll know from the video that if you put it into a neutral substance, which means neither acid nor alkali, it doesn't turn colour. It doesn't change colour. Okay. That was a no slide, so we can go back to that one. Okay, you can pause it and you can make sure you've got some information down. You might already have this down from making notes when you watch the video. That's fine. Okay, now this is a different kind of indicator. I'm not going to ask you to draw this one out now because there is a worksheet attached to class charts which you can fill in or colour in. Universal indicator is a whole range of colours. Now luckily for us it goes the same colour in acid, strong acid, as litmus paper does. And it goes the same colour here in our alkali as litmus does. Okay, but the difference here is we've got a range of colours. Up until 7, and the colour for 7 is a green colour, that indicates that we've got neither an acid nor an alkali, okay, nor a base. So it means it's neutral. Okay, so this is very strongly acidic, and the acid gets weaker, although the numbers are going up until we get to 7. And here's some examples. So when we were talking about a lemon the other day, and the fact that we can eat a lemon, okay, this is got an acidity level of 2, because this is illustrating the pH scale, okay? Right over to here, and this is increasing alkaline here. So this is a weak alkali, and this is a strong alkali. Now, the next slide, okay, tells you why we might use universal indicator, okay? So the pH scale attaches a number called the pH value to each of those universal indicator colours. Now you'll see the previous chart started at 0. So sometimes they start at 0, sometimes they start at 1. What we mean is 0 or 1 is a strong acid. So litmus only tells us whether we have an acid or an alkali, or whether we don't have anything, whether we don't have either of those, but it won't show us how strong the acid or alkali is. Okay, so if you need to know how strong your acid or alkali is, you'd be better off using the indicator called universal indicator, and that goes this range of colours. Alright, so you can make notes on that previous slide. Okay, so if I go back, you can pause the video now, okay, and make notes. But if I go forward, here's just a little bit more information. So these are the acids. pH numbers 1 to 6 are acids, or 0 to 6 if you've actually got a 0 on your scale. And these are the alkalis. So the alkalis from 8 to 14. Do you remember what number 7 was? That's right, it's neutral. That's a really good diagram to have down in your books, but if you use one of the worksheets attached, you'll find it on there as well. Okay, so these are the things we need to know. I know it's the third time you've seen this slide, but we're just going over the points to make sure they sink in. pH 1 is a strong acid, pH 6 is a weak acid, pH 8 is a weak alkali, pH 14 is a strong alkali, and here's our neutral position. Okay? Alright, you can pause the video if you want to make more notes. Now, here are some chemical formulas. The plural is actually formulae of some different types of acid. And I'm going to tell you what the acids are in a minute. This is a very common one. It's got two things in it, okay? Can you see, even if you don't know what these letters of the alphabet stand for, can you see, looking down, what's the common factor in all of those acids? You can write it down and see if you're correct in a minute. Pause the video. Now, some of you might have been tempted to say oxygen, and oxygen appears in nearly all of them, but oxygen doesn't appear in this one, so this one's a bit of a limiting factor here. So the common factor in each of these is that they do actually contain this H, which some of you might know stands for hydrogen. Now that little 4, the number there, means you've got 4 hydrogens in this compound here. Okay, whereas this one's only got 1 because there's no number after it. This one's got 2. So what are these acids? You don't need to know this at this stage, although these two are quite common in the laboratory. This is ethanoic acid, hydrochloric acid, so hydrogen and chlorine, that's where these names come from here. This one's sulfuric acid, this one's nitric acid, this is phosphoric acid, and the last one is citric acid, and that's what's in our lemons. Okay, let's move on then. Now, it's time for you to pause the video and go and try 1 or 2 of the worksheets that are on class charts. First 2 are at a foundation level, so really good starter tasks, but if you're feeling that you're up for a bit more of a higher level task, then you can jump straight to the 3rd one, okay? You can't access them from here, but they are attached to the class charts work. Alright, so for the rest of the lesson, I would be doing those class charts activities, or you can pop back and look at the video again. Okay, so pause this video while you go and do this work here, these worksheets. Okay. Right, welcome back. If you finished your worksheet, okay, this is an extension slide, which means that you can write down your answer and use your own words. Okay, so if you only had litmus paper to use, so you haven't got universal indicator, write a numbered procedure. That means write me a few steps to find out if your unknown solution is acidic, alkaline or neutral. What would you do? Okay, pause the video and have a go at that. Alright, have you met any new words this lesson? Can you write a definition for them? This is a really good activity to try at the end of each lesson. If you're not quite sure what indicator is, go back to your notes and have a look. Okay? Right, well done guys. Good job for doing the work. And I think what I'm going to do is I'm going to see if I can attach the class charts worksheets to the Teams area as well, and then you can choose where you access them from. Okay? Excellent. See you next time.